Mm. Hello, everybody, and welcome to the very first lesson of Chapter 1 of the Statistics course for Health Sciences. I'm Professor Hussein, and I'm pretty excited to be getting going on this whole statistics journey with all you guys. This is going to be pretty darn good, okay, if I do say so myself. Now, for this first for chapter 1, I'm gonna break them all up into little pieces. Okay, so this first one is really gonna be like an introduction to statistics, and we're gonna go over a lot of different definitions and just trying to get a decent understanding of the basic concepts of statistics before we do before we actually look at real scenarios or like really dig into this. All right, so it's just gonna be this one is gonna be mostly let's just understand a couple terms and concepts for you guys, all right? First, what is statistics? All right, so statistics is the study of how to collect, organize, analyze, and interpret numerical info and data. So what does that even mean? All right, let me put this in a practical sense for you guys, something we can all relate to. Well, I don't think that people use Yelp anymore, but let's just use Yelp for this example, okay? So in Yelp, we have a bunch of, so in Yelp, we have, let's say you're looking for a restaurant, you plug it into Yelp for wherever city you're in at the time, and you're looking for a good restaurant to eat at. And then you're looking through the restaurants and you're going through the different stars. All right, how did the star ratings even happen? Okay, this was Yelp being able to collect the data. Okay, so collect the data. They gathered a bunch of data from all of the different people who use this platform, people who have gone to those specific restaurants, and had them provide their, opinion of their experience at that restaurant. Okay, and then Yelp gathered that data, okay, and it organized it and analyzed, interpreted that information, okay, so that it can give you an actual star rating for each restaurant on that platform, okay. And then of course they'll give you the raw data underneath, which are the reviews, right? So and see, the thing about statistics is that, it's like on one hand, you're going to see a bunch of restaurants that have like 5-star ratings and some that have 4-star ratings. So you're probably excited about going to those. And then you're also going to see some 2s and 3s, maybe even 1s that are horrible. But also think about that these restaurants, that star rating might not really be giving you the whole story about that restaurant, okay? Do we know how many reviews well, they usually give you that information, but that restaurant could be under new management now. Maybe things have changed. They could have cleaned up their acts, anything could happen. So statistics in a way is the science of uncertainty, and we're just trying to make sense of this uncertainty. But so we're going to try to use technology and extract information from data, but at the same time it's also uncertain. Okay, so why do we even use statistics? Why? Well, because it does help us gather data and kind of interpret it. Okay, we can put it into a practical sense, and it will help us make decisions on what we want to do. Okay, for example, we're all going through this whole pandemic thing, right? Well, the CDC is out there, okay, collecting data and organizing everything and analyzing the data and interpreting it in numerical information and all that, and then it's passing the interpretation of this data onto the public so that everyone can make better decisions about how they want to handle this. Okay, so, you know, that is a huge reason why we do statistics, right? So in this slide, I just wanted to be able to compare and contrast the meaning of individuals and variables in statistics and then outside of statistics in our everyday life. Okay, so in normal daily life, we probably look at individuals as people, okay? Like, and for example, a way you can measure people in any situation in life outside of statistics is you would probably say, hey, at this graduation or at this event, we expect 50 people to show up. Okay, 50 people bought the ticket, so we expect 50 people to show up. Okay, and a variable in outside of statistics, okay, a variable is a factor that can vary. Okay, it's not going to be consistent. It's not going to be the same thing every time around. Okay, and outside of statistics, we might see it as something that might be causing a problem. Okay, an issue. Got problems. All right. So an example of that could be maybe the time that the auto repair shop takes working on my car, getting my oil change done is an unknown variable. Okay, and I can't predict it. I don't know when my car is going to be finished. It's different every time. Who knows? That's a problem. Okay, because what if you have other appointments or you have things going on that day, and you know it would be great for you to get your schedule right. So though that is the meaning of individuals and variables outside of statistics. Now let's look at within the scope of statistics. All right, so an individual within the scope of statistics would could be people or objects. All right, an individual is like it's a thing. It's like one unit of something. All right, I don't know if that kind of makes sense, but it could be people or objects. It doesn't always have to be a person. Okay, so people are objects that are included within a study. So some examples of that could be, you could say 5 individuals could be 5 people, or 5 individuals could also be 5 records or 5 reports. Okay, now looking at variables. In statistics, a variable is a characteristic of the individual to be measured or observed. Okay, so and within statistics, we're not looking at something going, I don't know about that, you know, I can't measure it, I'm just gonna, it's a problem. Okay, no, we're not doing that. We're going, this is a characteristic of this individual. Okay, it could be a person, it could be a record, could be a report, could be anything, but we're going to observe, or we're going to measure a characteristic of this individual, okay, of this unit, of this thing that we're working on. Okay, so some examples of that could be the age of an individual person. So you're going to measure the age of that person, the time an individual record was entered. Okay, so that's something that you measured, right? Or I guess you can observe it. The diagnosis that's listed on an individual report. Okay, so those are variables within the scope of statistics. Okay, I hope that makes sense. Okay, so these are just some examples of individuals with some corresponding variables. Okay, so here's some individuals. Remember, individuals are people or objects, right? And then we have the variables that you could be measuring or observing, okay, that correspond to those individuals. All right, so first of all, we got a kidney dialysis patient. So something that you could be measuring in that scenario might be the number of blood transfusions. Okay. Number 2, you could be looking at babies that are born to a baby that is born to a mother who smokes cigarettes. Now, something that you could be measuring with individuals like that might be birth weight. Okay. Or Number 3, postmenopausal women. And something you could be measuring with that, measuring or observing with postmenopausal women might be compliance with health screening recommendations. Okay, so these are all different things you could be measuring, observing in the variables column, and then the individuals column are just things that are like really the focal point, the unit of that you're observing. Okay. So statistics, or concepts in statistics, is really important in healthcare, and also of course other disciplines as well, because it helps in decision making. Okay, when we can gather this data and really make sense of it, it can help us figure out exactly where to go from there. Okay, so what to do about that. Okay. Okay, so now we're going to get into parameters versus statistics. All right, so first within this, we're going to look at what a population is and then what a sample is. Okay, so what is a population? Well, a population is a group of people or objects, right? Because we're also think of individuals, okay? Population is a bunch of those individuals. Anyway, so a population is a group of people or objects with a common theme. Okay, so when every member of that group is considered, it is a population. Okay, so let me give you an example of this so it kind of like looks more obvious. All right, so let's say we wanted to, let's say we want to look at the nurses who work at St. Bernardine's Hospital, okay, in San Bernardino. And so we're going to describe the theme as nurses who work at St. Bernardine's Hospital. The population would include all of the nurses that work at St. Bernardine's Hospital, right? It would be everyone that falls under that. Okay, what if I said the theme is nurses who work in the United States? If we still use the population, okay, from the human resources of every currently employed nurse at St. Bernardine's Hospital, that wouldn't work, okay? Because the theme is saying all the nurses in the United States, okay? The theme is what has to define pretty much the parameters, right? And then you can, the population will be all of the individuals who fit within that theme. Okay, so if we said nurses who work at St. Bernardine's, then we can only be looking at the population of nurses who work at St. Bernardine's. If we said we're gonna study the nurses who work in the ER department at St. Bernardine's, then we can only be looking at the population of nurses that work in the ER department at St. Bernardine's. That is the population that we're looking at. We would not be able to look at the population of nurses in the entire hospital. Okay, so I hope that kind of makes sense. Okay, so now let's go back over here, or here, sorry, this way. What is a sample? So a sample is a small portion of the population. Okay, it's like taking a piece of that population and studying just a little piece, because it might be a lot of work to study everyone in that population. Okay, so we're taking a little piece so that's practical for us to study that. Okay, so that's a sample. Now, a sample can be a representative sample, but it can also be a biased sample. All right. We'll get into what biased samples are later, but you ideally want a representative sample. Okay, so let's look at an example. Okay, what if, for example, what if we want to survey ICU nurses at St. Bernardine's Hospital? Okay, and going back to the same population up here, the same population example, remember, we were saying that the theme is going to be all the nurses that work in the St. Bernardine's Hospital, which means our population is all the nurses that work at the St. Bernardine's Hospital. So if we only survey the ICU nurses at that hospital, that's not going to be a representative sample. That sample does not represent all of the nurses in that population, does it? It's kind of biased, isn't it? No, it does not. It's not a representative of that sample. What would be a representative, a good representation of sample of that population would be if we maybe surveyed one nurse from each department. Okay, so that would cover all the nurses who work at the St. Bernardine's Hospital. I hope that makes sense. Okay, now we're gonna look at, two different types of data, okay, data collection, okay. So we're gonna look at population data versus sample data. And, okay, so let's look at population data. All right, population data is data from every single individual in the population. So going back to where we were, let's say you have your theme, where your theme is all of the nurses that work in the St. Bernardine's Hospital, okay? Well, if we were going to collect population data, that would mean that we would have to collect data from each nurse that works there. There could be hundreds. Okay, well, I don't know how many people work there, but we would be collecting data from each individual nurse. That is actually, when you're collecting data from each individual in the entire population, that is called a census. Okay, I think you guys are a little bit familiar with the word census because this year was the year that we did census, right? Usually the United States collects data on every single individual every 10 years. Okay, so this was the year census was happening, and I think now they want COVID info and all that, so that's besides the point. So when you're doing population data, you're collecting a census, okay? You're getting all of the data from each individual within that population, okay? Now, sample data, on the other hand, you're not getting all the data from each individual, okay? You are just taking a portion of the individuals within that population, and you're expecting, or you're just assuming that the sample that you chose to collect data from is going to represent the population, okay? So this is actually way more common to use than that, okay? That's way less common. This is the more common thing to use in research. You usually want to collect a sample data, okay? Just because it's so much easier. I mean, unless it's absolutely necessary for you to gather information on each individual within the population, usually we're just going to use a sample and have that represent the population, okay? Okay, so statistical notation. Sorry. So this is like a secret code, kind of. Shh, don't tell non-statistic students. Okay, this is our secret. Okay, it's like a secret code, secret club. Only we know what these letters and such mean. So now you guys are part of it. Congratulations. All right, so capital N, when you see a capital N, that is going to represent the total population. Okay, and when you see a lowercase n, that is going to represent the sample population. Okay, so if it says like n equals 25, you know that 25 is the total population. Or if it says lowercase n equals 4. You know that 4 equals the sample of population. Okay? So super simple, but it's a secret. Ooh, we're really uncovering the code now. Okay, so parameter versus statistic. A parameter, notice that it starts with the letter P. Okay, so parameter, I just want you guys to remember, it starts with the letter P. Okay, so, and P also is the first letter of population. Okay, so parameter is a measure that describes the entire population. Okay, now a statistic starts with S, all right, and guess what else starts with S? Sample. Okay, so a statistic is a measure that describes only a sample of the population. Okay, the parameter describes the whole population. The statistic describes a sample of the population. Okay. Okay, so here are some examples of parameter versus statistics. So remember, the parameters describe the population, the total population, and then the statistics describe a sample of that population. So you can go ahead and look at these examples yourself, but we'll look at the last one together. Okay, so number 3, actual voter turnout. So this would be a parameter because it's talking about the entire American population who voted. Okay, so the actual voter turnout, meaning all, like gathering data from all of the people who voted. Okay, versus number 3 on the statistics end. Okay, the proportion of people in opinion polls who say they plan to vote. So this is just a sample. It's a proportion of people, okay, who have given their opinion polls to say that they plan to vote. So this isn't even during the actual election. This is just a sample of people who say that they are going to vote. Okay, so it's not the entire population. Does that make sense? So I just really want to push the ideas of parameter versus statistics in your minds. All right. So because I know that the news and whatnot, they can kind of mix and match these words. They sort of throw them around. So anyway, there are clues that you can look for when you hear on the news or anywhere else, like in a podcast or something like that. If that can tell you if they're talking about a population parameter or a population statistic. Okay, so some clues of a population parameter would be that a data set was actually used to encompass the entire population. Okay, like for example, Medicare. Okay, or analysis were actually done by the government. If it's a government thing, then yeah, odds are likely the government isn't going to sample. The government's going to census, all right? The government is going to get information from everyone. The government knows everything, all right? You can't hide. So if it's a government kind of thing, then most likely that was a population parameter. It was a total population kind of deal, all right? So some clues about whether or not it might be a statistic or a sample statistic, okay, where they are only looking at a sample size, might be like sometimes in studies they'll say, oh yeah, we gathered data from volunteers, or we recruited volunteers, or participants. Okay, participants is a big word that you use in research. Okay, participants. Anyway, so the thing is that no, not everyone is going to volunteer to provide data. Okay, so that's a huge clue that this is a sample statistic, not a parameter. Also, the report might mention only surveying or measuring samples of individuals, or even if they don't. If you hear the words polling, okay, and things like that, that might indicate a sample statistic. Not all the time, but usually that would be it, okay? Because Like, for example, on the news, when they try to collect information, they want to poll everyone and see like who they want to vote for, so we can see like who's in the lead. Whenever we have campaigns that are going on, upcoming elections and all that, they're not going to go after every single individual in the United States and ask them who they want to vote for. Okay, that's a lot of work, that's a lot of money. And we're going to save that for the actual voting day. So just to kind of see where we are, they're going to use sample statistics. Okay, they're just going to take a sample of what it looks like, a sample of the population of the United States, and kind of see what it looks like people might want to do. Okay. So now let's look at inferring versus describing, or describing versus inferring. How I read that out of order, I'm sorry. But okay, so let's look at descriptive statistics, because this is a lot easier, a lot cleaner, a lot nicer. All right, so descriptive statistics involves methods of organizing, picturing, summarizing information from samples and populations. This is like you're giving some good old-fashioned data, and then you're making some nice little graphs with it, like nice little bar graphs and charts, and it just shows you what's going on with the population right there, and you can just see it and go, it's going up here, it's going down there. We conclude such and such is happening with this population because it's very obvious on the graph. It tells us right there. It's very descriptive. Okay, so that's descriptive statistics. It describes what's going on with the population just right there. Okay, now let's look at inferential statistics. Let's kind of understand the word inferential, okay, to really understand inferential statistics. All right, so if you don't know what inferential means, it's kind of like pretend that you have a friend who doesn't want you to come over in the evening times. Like, it's just too late, that friend has to do homework, they do not want to be bothered past 6 o'clock, okay? But they don't want to tell you that directly. They're not going to be descriptive about it and be like, this is what I want you to do. Do not come over past this time. Okay, they're not going to come out and say that. They're going to imply, all right, with their words. Okay, so let's say they hint that they do not want you around past a certain time because they're busy with their homework. Okay, well, maybe you got the hint. So you could say that you inferred. Okay, you kind of get what they are trying to tell you. I got you, girl. I figured it out. You don't want me to come over past 6. Okay, I won't. Okay, so you inferred. Okay, you inferred that that was the case. Okay, that's what was going on there. You took that data that that person was giving to you or trying to communicate, and then you inferred something and came up with a conclusion and decided that's what that is. Well, inferential statistics is kind of like that. It's like you have to infer your own conclusions about what's going on with the data. Okay, it's the data will provide you with some information and you have to study the data, okay, and try to draw your own conclusions regarding the population. So you figure out, you look at the data and you go, I think the population is doing such and such, so we need to take this action. It's not descriptive, it's not making it obvious for you, you have to infer it, okay? I hope that makes sense. So in statistics, it's actually really important to properly identify the measures as population parameters or sample statistics, because population parameters, remember, that's data for the entire population, which, I mean, really, that would be the population, or the data is just telling you exactly what it is. It's drawing conclusions on exactly what's happening with the population, okay? But in sample statistics, you're taking a sample and, figuring out some data and going, okay? Now, in that situation, with sample statistics, you can actually be, inferred statistics, okay, inferring statistics can only happen with sample statistics. You cannot use it for population parameters, okay? So it can only be used on sample statistics because sample statistics is like really the only thing that can actually provide you a mystery, if you want to look at it that way. So it's not as clearly defined there. However, in a population parameter, of course, it would be clearly defined. Okay. Okay, so now we're going to start classifying variables. Okay, and classifying variables is pretty much, I guess you could think of it as a 4-level system, but it starts off as first classifying your variables as either quantitative or qualitative. Okay, and then within whether or not it's qualitative or quantitative or qualitative, that would decide whether you can further classify them as either interval versus ratio or nominal versus ordinal. Okay, so we're going to go ahead and figure out or learn about what those actually are. So now we're going to look at qualitative and quantitative. Woo! Okay, so first let's go to quantitative. Quantitative. Quantitative, this is a numerical measurement of something. This is you putting a quantitative value on something, okay, a numerical measurement. So some examples of quantitative variables in healthcare, and these are quite common quantitative variables in healthcare. So time of admission, so it could be like you were working in the ER and you want to look check out what the average time of admissions you're getting for the patients that came in, or even your diagnoses. Then there's systolic blood pressure. Okay, remember, well, I don't know if you guys have taken anatomy, but you guys can Google that. It's not important for this class. You don't need to know. Anyway, and then there's platelet count. So these are all different examples of quantitative variables in healthcare because you can put a numerical value on those. Okay. Now, a qualitative variable is something that refers to a quality or categorical characteristic of something. Okay, so you're assigning quality to it, not quantity. So some examples of that can be type of health insurance. Okay, you're putting that in a category. All right, so you're assigning a categorical characteristic to that, and you're saying these are the different type of health insurances, and then maybe you're doing like a survey on a sample of people living in San Bernardino, and you want to see what types of health insurances that everyone is using. What if you want to also maybe survey and get what countries all of the people are from in a certain population, maybe in a certain hospital or whatever, it doesn't really matter. But just for the sake of this example, you could also look at stage of cancer or trauma center levels. So you can assign quality levels, okay? Or, well, actually, those are more established levels, but they're not levels of measurement, okay? That you're not going to assign a numerical value to these different levels. These are levels of quality that we have assigned to, certain stages or, something like that. So that's kind of the difference between qualitative and quantitative. Qualitative looks at the quality of something. Quantitative is quantity, or how many. All right, so you assign a numerical measurement to it. Okay, so interval versus ratio, these are both different types of quantitative variables, right? So looking at interval, this is, well, both of these. Okay, let's look at their similarities, and then I'm gonna explain what makes them different. Okay, so both interval and ratio, these are both quantitative, continuous numerical value pieces of data, right? They both have differences. The differences between the data values of each of these is meaningful, and that means that like with each different value that you could have in your data, each single value is meaningful. They're distinguishable. They're different from each other. It's like going up in levels, okay, or having different numbers, So each different value has its own, is separate and more meaningful, okay. Where they differ, okay, how you can tell what is the difference between interval variables and ratio variables, okay, is that the interval and interval variable values, there is no true zero. So it holds no true zero. And that means that it can actually have values that are below zero. Like, for example, you could, in this case, you could be measuring like the temperature, okay? And so there can be hot temperatures, but also temperatures can go below zero, right? So you could be measuring values below zero, and those would be meaningful here. On the ratio side, okay, ratios, they can hold a true zero, okay, so true zero exists, and that's pretty much like the stopping point, okay? So you can't have values in a ratio variable that go below zero. It's like 1 and above, you know what I mean? Well, not 1 and above, but nothing can go underneath zero. You can't have any negative values, okay? So that's the difference, the main difference. Okay, so here are some examples of ratio and interval. Okay, so if we use examples, if we're considering like time of admission, like in healthcare, or year of diagnosis, or the systolic blood pressure readings, or platelet count, so we can take those and put those where they would be in with respect to what type of quantitative variable values you would get, right? So as a ratio, remember ratio variables, there is a true zero. It does hold a true zero. Zero exists, okay? So the types of values that you can use for a ratio would be the systolic blood pressure and then the platelet count. Okay, because systolic blood pressure, that's your blood pressure. If you ever hit zero with your blood pressure, you would not be alive, right? Okay, so you can't get like negative numbers with systolic blood pressure. Same thing with platelet count. If your platelet count hit zero, you would not be alive. So you can never have zero or negative numbers with that. It's always higher numbers. Okay. Now with interval, this has no true zero, meaning you can have smaller values than zero. You can go negative. Okay. Or it just really you can't have, there is no true zero that exists. And time is a funny thing, because I know there are no negative numbers in time, I get that, but time itself cannot actually have a true zero because it's continuous. If you think about the clock, there's no 0 o'clock, or I mean, I guess maybe you would call midnight, or midnight or 12 a.m. or something like that, but dude, I don't know. Anyway, just we know, okay, that time has no true zero. Okay, so just know that, memorize it. Okay, time has no true zero. Okay, and therefore, if you're going to measure time in your quantitative study, the time as a variable will be an interval variable. Okay, and same thing with year of diagnosis, obviously, because that is time, right? Okay, so now we're going to dig into the qualitative type of variables. So these ones are going to be nominal or ordinal. Okay, so nominal ones, this is going to apply to categories, labels, or names that cannot be ordered. Okay, they can't be put in any kind of natural order from like small to big, or less than to greater than, or like less severe to more severe, or you know, you get the idea. So you can't really order them. All right, so there's no order there. So some examples that you would use for nominal variables might be, you know, all the different types of health insurance. Okay, because you can't really order the different types of health insurances, right? Also, you know, country of origin, you can't really put those from, I mean, I suppose you could measure them, but anyway, if you're using it as a nominal variable, the any kind of numerical value or any sort of order does not matter. Okay, that's not the purpose for why you are using a nominal variable. Okay, now ordinal is a little bit different. Okay, so ordinal applies to data that can be arranged in order in categories. Okay, but the difference between the data values cannot be determined, or is either cannot be determined, or they are just meaningless. They don't really matter. Okay, so the differences between the values, they don't really matter, but they can be ordered. Okay, so it's kind of like maybe you're looking at, what if you're looking at like the different stages of cancer or something. Now in your study, you're not actually putting any numerical value on it, so the differences between the data values in each different level don't really matter because you're doing a qualitative study here. So that part's meaningless. However, you can arrange the different stages of cancer from like stage 1, then 2, then 3, then 4, you know what I mean? So you can arrange them in a natural order because you're not going to jump from 1 to 5. You're going to go 1 to 2 to 3 to 4, like that. Okay, so ordinal is implying that there is a natural order in which they can all be arranged. The different categories can be arranged. Okay, even though the differences in the categories or the differences in the different levels that you're doing don't really mean anything. Okay, they don't actually mean anything to the study because this is a qualitative study. You're looking at the qualities, not assigning numerical values as you would in a quantitative study. Okay. Okay, so just recapping a little bit on classifying variables. First of all, when you're given a study or anything and you're asked to look at the variables and all that, it should be obvious now that you can classify them as either quantitative or qualitative. And it's pretty obvious like how you can, like which one is which. The quantitative guys, those are the numerical value ones. Those are the measurements and numbers and math. Okay, well, there's still some math and qualitative as well, obviously. And then qualitative is where we're looking at, you know, qualities and things like that. So that's how you can distinguish that. And then once we know which is which, we can figure out if they are interval or ratio or nominal and ordinal. Okay. And the thing is, it is actually important to be able to figure out what is what, at least at the basic level, because especially in healthcare, because once we actually know what the data is going to give to us, like what we're studying, which variables are being studied in this particular research, then we can kind of figure out exactly what we want to do with it, because depending on the type of information that you're given in a study, that's going to determine like where you can go from there, you know? So I hope that you guys learned something. I hope this was informative. I hope it helps. There will be, I think I'm probably going to have to do like around maybe 2 or 3 more chapter 1s. I know this is quite a bit, but this is information that we need to know. Especially, so I told you chapter 1 is going to be kind of a big one. We may use a little extra time, but whatever. All right, so keep a lookout for the other ones. They will be coming up shortly, but please enjoy this one.